This is Introduction to Meteorology, and I thought we could start out by just looking a little bit at the weather to what's going on now. This is what we're going to be exploring each week. The idea is to build up to where you actually see what goes into making a forecast. However, we've got to start down at the very basics, so we're just going to overview what weather is. This is a weather map. You're going to see lots of these. This is a surface one. What you see plotted on each of these little circles here is what the current weather is at that given location. Notice I said current weather. Weather is the instantaneous thing. In other words, if you walk outside right now, that's the weather currently. If you want to know what the weather is going to be an hour from now, that's a forecast of the weather. And there is a significant difference there. What's happening now is what we're going to talk about today. We're going to try to understand a little bit about what the atmosphere is, what we're dealing with when we forecast the weather, and some of the things that go into it. So on this map are high pressure systems. Winds blow around the high pressure system clockwise, like the hands of a clock. You'll see winds just flowing right around this high, which means along the east coast of the United States right now, winds are coming out of the north and actually pushing this cold front down to the south a little bit. West side of the high, winds flow from the south, and we have here a warm front coming north. Warm fronts have red, typically semicircles on them, blue cold fronts, and here's low pressure, which has counterclockwise winds around it. None of these systems are strong, which is very typical for this time of year. Notice across the southern part of the United States, big high pressure system covering most of the southern part of the United States. High pressure systems typically bring good weather. Low pressure and fronts bring bad weather. Simple way of thinking about fronts is if cold air is moving into your area, it's a cold front that's moving in. If warm air is coming in, it's a warm front. So that is the very basics of weather. We're going to be looking at these charts in your weather studies manual, especially in the next first few weeks here. We're going to be talking about how we observe these observations, what each one of these points was representing. In other words, if I told you to walk outside and tell me what the weather is, I bet each of you would have just slightly different definitions of that. And as observations go, we want to know very specifically such things as temperature, how much moisture is in the air, wind speed and direction, maybe what the pressure is of the weather, the atmosphere at that point. All of that contributes to our being able to know what the weather is now. Oh, yeah, is it cloudy? Precipitation occurring? And I want to be able to put that into a forecast and tell you an hour from now, 72 hours from now, maybe 120 hours from now or more, what that same conditions are going to be. In other words, each one of those things I just listed, I want to be able to describe to you at that time in the future. So first, we're going to look here at another way of observing the weather. I'm going to throw up an animation of the CONUS United States with visible satellite. This is like you're looking at the atmosphere from above. In other words, you're in a spacecraft and looking down. This is what you're going to see. However, I added one extra little thing. These green, red symbols here are lightning strikes. You'll see some here going across just south of West Virginia, on across eastern parts of the border right between South and North Carolina here, and some other ones down in Florida as well. And even some out in the Rocky Mountains today. So these are lightning strikes combined with visible satellite. You can actually see clouds moving along here to the east quickly. And you can watch these clouds develop down here. These are cumulonimbus some of these, and cumulus clouds are others in here. We can see the weather in the tropics, see what's going on down there. So we're getting a good overall view of the weather from this type of satellite image. There are also infrared satellite images. Infrared is just seeing the temperature of the cloud. So where I can use this during the day, I cannot use it at night. But at night I can use infrared and I can see what the temperatures of the clouds are. By knowing that, maybe I can tell how high the clouds are, and even if there are any clouds. Finally, I wanted to show you one other thing, which is just radar. It's a little more complicated. This is just looking at the intensity of precipitation. You used to see some greens and yellows in here, some down this way. Pretty strong thunderstorms developing down here in the southwestern corner of Virginia, moving out along that whole line right there. This is radar. Radar picks up. The radar that's picking up on these is actually up in here, pointing south. So it's not observing the weather where it's at. It's observing the weather down to the south. This is remote observations. We'll talk more about that as well. And radar has the advantage also of being able to see wind motion in a storm or overall looking at it. And we can even tell with dual pole radar something about what type of precipitation may be occurring and how much. So that just gives you a general flow of where we're headed in the weather today. So let's look now at monitoring the weather. That's what the first chapter is all about, just monitoring it. In other words, observing. So if we want to observe the weather, what are some of the things we want to look at? Well, they give you a little bit of what's happened in other times here. If somebody was observing the weather in the blizzard of 1888, they'd have seen a heck of a lot of snow occurring along the East Coast. And some other extreme snowstorms have occurred at times. You can see the pictures here. So we would want to understand what's causing that. And I showed you some surface observations, some satellite, some radar. Didn't show you radio sondes, but that's another method of observing what the weather is right now. And remember, I said the weather is what's happening now. It consists of quantitative variables. What are these? Quantitative means they're a number. In other words, temperature. I'm not telling you it's cold outside. I'm telling you the temperature is 23 degrees or 65 degrees. I'm telling you what the humidity is. Again, it's a value. The amount of cloudiness. I'm not saying that the skies are, it's generally cloudy or whatever. I'm saying what percentage of that sky is covered with clouds. All these are quantitative. Meteorology is just the study of what makes these variables change, what influences the weather systems. Climate, if I want to know climate, I am averaging the weather over long periods of time. A climate variable would be when is the typical first date of frost at my house? When does the growing season begin? When the last date of 32 degrees typically is. That's climate. How much rainfall does my house average in a year? How much snowfall? Those are climate variables, and climatology is the study of climate. All right, so if I need the weather observations at the same time, that means that we know times change as you go across the United States. So the Eastern time zone time is 7 a.m. Out in the Pacific is 4 a.m. But that is the same time that I'm observing the weather. So in other words, I am looking at the weather will change clock time, but not weather time. How about that? And here are the different weather systems I just showed you, talked about them. And yes, remember, winds around high pressure, clockwise. Around low pressure, counterclockwise. Notice that they flow inward towards the low and outward away from the high. That's going to become significant later on. Fronts. All right. Warm air tends to rise over cold air. So that means That warm air, when there's a cold air mass here, but a warm front's advancing, the warm air actually lifts up over that air mass, stretches well out ahead of it. So as the warm front's advancing, you wind up with lots and lots of clouds, light precip, well before the warm air gets to you. You can many times watch cirrus clouds develop, then maybe lower clouds gradually becoming overcast, and then precipitation as the warm front's approaching. Cold fronts, when they're advancing, cold fronts are very steep. In other words, they push the air up very quickly as they're moving along. These tend to form a lot of cumulonimbus clouds, big fluffy clouds. Oh yeah, fronts are three-dimensional. In other words, the atmosphere isn't just at the surface. It extends up well through the tropopause, through the troposphere, and fronts do the same. So in other words, when I am just showed you that front, that warm front kind of sloped up over the cooler air ahead of it, that's a three-dimensional. In other words, if I was 100 miles away from that front, I still need to know that, well, I might have a warm front aloft over me that's causing those clouds. And some fronts do not have any clouds or precipitation with them. They just kind of pass through. They may shift the temperature. There's a front called the Blue Northerner in the Midwest that sometimes comes through dry in the middle of winter, but it can drop temperatures 30 to 50 degrees because it brings in extremely cold air, but has no distinguishing marks with it except for a wind shift and very, very steep drop in temperature. So some of the states of the atmosphere, we want to know the maximum temperature of the day, minimum temperature. That can make a heck of a difference about what I'm going to wear outside. Maybe not for some people, but it does for me. Dew point. All that is if I took the air that is outside, cooled it, one would dew form. That's all it's stating. That tells me how much moisture is in the air. Relative humidity is how close to that saturation dew forming the air is. Precipitation, air pressure. Air pressure, we talked about high pressures and low pressures. I want to know if they're coming near me or a front's approaching. So typically a cold front or a warm front is going to have lower pressure with it. So as it's approaching, the pressure might be dropping. That may signal to me what may be happening in the weather. Wind speed and direction. Very important, especially if there's really strong winds. Sky cover. If you wanted to go outside and sunbathe, you might not want to be a totally cloudless, cloudy sky. And there are various watches and warnings of weather service issues. All right, I showed you a satellite image. It's taken from a geostationary satellite that's 36,000 kilometers up, sits over the exact same spot. So in other words, it is a continuous picture. And we do get 1 minute or less images off of that satellite. So we can really look in detail at how those clouds are changing over very short periods of time. Polar satellites, they're lower, they have a better resolution, but at the same time, they don't go over the same area except for twice during a 24-hour period. So while that resolution's nice, kind of missing some features. And here you can see that infrared, like I showed you. Yeah. Here are some clouds. Notice the wispy ones on the left here are cirrus clouds. They're up very high, composed of ice crystals. The lower ones on the right here, little cumulus clouds, are more composed of water. They're darker, have more defined edges. Fog, just a cloud in the ground. There are a lot of hills in West Virginia, and many times when you're driving along at the top of the hill, there may not be any fog, and as you go down the hill, fog could get very dense. Other kinds of clouds are stratiform clouds. These are layers of clouds. They're at the same altitude, look very similar and very smooth. They move in different directions because the wind speed changes at different elevations in the atmosphere, but they're very smooth. Cumuloniform clouds are bubbles in the sky, literally like cotton balls. And when they come together, they can get to be a cumulonimbus cloud, which can be very much different, much stronger weather. And like I indicated, clouds do move in different directions depending on the winds at that elevation. So we bring all this together to observe the weather. What's happening now is that weather. So let me know if you have any questions.